A lone yellow evidence marker winks under the harsh glare of the police lights. It sits beside a shattered window, a silent sentinel in the otherwise chaotic scene. Inside, a body lies still, a single bullet wound marking the point of impact. There are no witnesses, no obvious signs of struggle, just the chilling tableau of a life abruptly ended. Yet, amidst the despair and the urgency to find the perpetrator, a glimmer of hope emerges. It lies in the form of a small metallic object, the bullet. This tiny piece of evidence holds the potential to unlock the secrets of the crime, to give a voice to the silenced victim. It is here that forensic ballistics steps into the limelight, its practitioners poised to unravel the intricate puzzle of the crime, one bullet at a time. Forensic ballistics, a captivating realm where science meets justice, plays a crucial role in modern criminal investigations. It is the science of analyzing firearms and ammunition used in crimes, providing crucial evidence for solving cases. The trajectory of a bullet, the markings on a spent cartridge, the residue on a suspect's hands, these are all pieces of a puzzle that ballistics experts meticulously piece together, often making the difference between a cold case and a conviction. The absence of eyewitnesses in many crime scenes amplifies the significance of forensic ballistics. Bullets, often the only tangible connection to the perpetrator, become silent witnesses. Their journey from the barrel of a gun to their final destination leaves a trail of information, a story etched in metal, waiting to be deciphered. It is this story that forensic ballistics aims to uncover, providing crucial evidence for the courts and aiding in the pursuit of justice. The early 20th century marked the dawn of forensic science as a distinct discipline. This period saw the emergence of pioneers like Edmond Locard, who established the first forensic science laboratory in Lyon, France. Locard's exchange principle, which states that every contact leaves a trace, laid the foundation for the systematic analysis of evidence at crime scenes, including firearms and bullets. As firearms technology advanced, so did the need for sophisticated methods to analyze their use in crimes. The unique striations etched onto bullets by the rifling inside a gun barrel provided a crucial breakthrough. It was discovered that these markings were akin to ballistic fingerprints, capable of linking a bullet to a specific firearm. This realization revolutionized forensic investigations, offering a tangible link between a weapon and a crime. One of the earliest recorded instances of ballistic evidence used in a court of law dates back to 1835 in England. In the case of Rex v. Richardson, a murder trial, Henry Goddard, a Scotland Yard Bow Street runner, used rudimentary ballistics to connect a bullet retrieved from the victim to a mold found in the suspect's possession. This landmark case underscored the potential of ballistics in criminal investigations, paving the way for its further development. At the heart of forensic ballistics lies the principle of individuality. Every firearm, due to the manufacturing process, possesses unique microscopic imperfections within its barrel. These imperfections, known as rifling, are imparted onto the bullet as it travels through the barrel, leaving behind telltale grooves and markings. Rifling consists of spiral grooves cut into the barrel's internal surface. These grooves cause the bullet to spin as it exits the muzzle, improving its accuracy and stability in flight. The spaces between the grooves are called lands. As the bullet is propelled through the barrel, the lands and grooves etch unique striations or microscopic scratch marks onto its surface. These striations are as unique as fingerprints, acting as a ballistic signature of the firearm. When a bullet is recovered from a crime scene, ballistics experts fire test shots from a suspect firearm using a water tank or other controlled environment. They then compare the striations on the test bullet with those on the crime scene bullet under a comparison microscope. If the markings align, it confirms that the bullets were fired from the same gun, providing irrefutable evidence linking the weapon to the crime. The 1920s case of Sacco and Vanzetti stands as a chilling reminder of the power and the limitations of early forensic ballistics. Accused of robbery and murder, Sacco and Vanzetti, both Italian immigrants with anarchist leanings, became embroiled in a trial fraught with political tension and anti-immigrant sentiment. The prosecution's case hinged heavily on ballistic evidence. Experts testified that a bullet recovered from the body of the murdered paymaster matched test bullets fired from Sacco's pistol. However, the defense argued that the tests were inconclusive and that the political climate unfairly influenced the jury's decision. Despite widespread protests and appeals, Sacco and Vanzetti were convicted and sentenced to death. The case sparked international outrage, with many believing the men were targeted for their political beliefs rather than concrete evidence. The Sacco and Vanzetti case, though ultimately ending in tragedy, highlighted the burgeoning field of forensic ballistics and its potential impact on the judicial system. Section 5. Modern ballistic arsenal. Modern forensic ballistics has evolved into a highly sophisticated discipline armed with an array of advanced tools and techniques. Gone are the days of relying solely on visual comparison of bullet striations. Today, ballistic experts utilize a combination of cutting-edge technologies and sophisticated databases to link firearms to crimes with remarkable accuracy. One such technological marvel is the Integrated Ballistics Identification System, or IBIS. This powerful database allows investigators to enter digital images of fired bullets and cartridge cases recovered from crime scenes. IBIS then compares these images against a vast network of ballistic data searching for potential matches. When a potential match is found, it is flagged for further examination by a trained ballistics examiner, who makes the final determination of a match. Gunshot residue analysis, or GSR, is another vital tool in the modern ballistics arsenal. When a firearm is discharged, it expels a plume of microscopic particles composed of burnt and unburnt gunpowder, primer residues, and traces of metals. These particles are deposited on the shooter's hands, clothing, and surrounding surfaces. By analyzing samples collected from suspects and crime scenes, forensic scientists can determine whether an individual has recently fired a weapon. Section 6. The Court of Law and Ballistic Evidence. The journey of a bullet from crime scene to courtroom is a long and arduous one. Ballistic evidence, while compelling, is not without its critics and challenges. In recent years, forensic science, including ballistics, has come under intense scrutiny, with questions raised about its scientific validity and potential for error. One of the primary criticisms leveled against forensic ballistics is the subjective nature of bullet comparison. Unlike DNA analysis, which relies on quantifiable data, bullet comparison involves a degree of subjective interpretation by the examiner. While guidelines and protocols exist, there is still an element of human judgment involved in determining a match. This subjectivity has led to concerns about the potential for error, particularly in cases where the striation markings are not clear or where there is a limited number of matching points. Another challenge facing forensic ballistics is the issue of wrongful convictions. Several high-profile cases have highlighted instances where individuals were wrongly convicted based on faulty ballistic evidence. These cases have underscored the importance of rigorous quality control, standardized protocols, and ongoing research to improve the reliability and accuracy of ballistic analysis. Section 7. Technological advancements, a new era of ballistics. Despite the challenges, forensic ballistics continues to evolve, driven by relentless innovation and a constant pursuit of accuracy. Emerging technologies are pushing the boundaries of what's possible, promising to revolutionize the field and bolster its reliability in the years to come. One such groundbreaking technology is three-dimensional scanning. Traditional ballistic analysis relies on two-dimensional microscopy, which can be limited in its ability to capture the full complexity of bullet striations. Three-dimensional scanning, on the other hand, allows for the creation of highly detailed, three-dimensional models of bullets and cartridge cases. These models can be rotated, zoomed in on, and analyzed from any angle, providing a level of detail previously unattainable. This enhanced visualization enables examiners to identify and compare minute markings with greater precision, potentially reducing subjectivity and improving the accuracy of ballistic analysis. Artificial intelligence, or AI, is poised to further transform forensic ballistics. Researchers are developing AI algorithms capable of analyzing ballistic images and identifying potential matches with remarkable speed and accuracy. These algorithms can sift through vast databases of ballistic data, flagging potential matches for human examiners to review. AI has the potential to significantly expedite the analysis process, reduce backlogs, and free up human examiners to focus on more complex cases. Section 8. The future of forensic ballistics. As technology continues its relentless march forward, the future of forensic ballistics appears bright, promising even more sophisticated tools and techniques for solving crimes. Nanotechnology, for instance, holds immense potential for analyzing gunshot residue. Researchers are exploring the use of nanoparticles to detect and analyze even the smallest traces of GSR, potentially providing more sensitive and reliable results. Furthermore, advancements in imaging technologies such as hyperspectral imaging could allow for the analysis of bullets and cartridge cases at a molecular level, revealing even more subtle differences and enhancing the ability to link firearms to crimes. The integration of virtual reality and augmented reality into forensic ballistics is another exciting avenue for future development. Imagine a world where investigators can don VR headsets and virtually step inside a crime scene, reconstructing the trajectory of bullets and gaining a deeper understanding of the events that transpired. The fusion of these cutting-edge technologies with human expertise will undoubtedly shape the future of forensic ballistics, ensuring that even the most challenging cases can be solved and that justice is served one bullet at a time.